All right, here we go. Here's a video on the Algebra 2A quiz on one-step addition and subtraction inequalities version 1. And I thought what we would do is go over the story problems because those are difficult for a lot of us. So we're jumping to problem number 13 here. It says there are W work days this month. Brian is going to miss 3 days of work this month. And then we have two parts. Part A asks us to write an expression for the number of days Brian will work this month. So first thing we want to make sure we understand is that an expression has no equal sign and no inequality. So we don't need to say like, we're doing inequalities, so this expression, something greater than 3 or less than or equal to 20 or something. I don't know. We don't need that for the expression. We just need to say we're going to add, subtract, multiply, divide, something like that. And we're going to use W, our variable here, should probably be involved in the expression. So I'm hoping for an Algebra 2 class that you would be able to just read this and go like, oh yeah, I got the expression. But I understand that sometimes it's difficult. So what we can do here is we can kind of pretend that we know how many workdays. Pretend we know this number. So if we say, I'm going to see if I can squeeze this in here, but to kind of make a little table here, if we say, well, the number of work days, let's pretend we know that. And then let's figure out if we had a number instead of a variable, if we had a number of work days, could we say how many days Brian will work? So if we pretend, for example, let's pretend there's 30 work days in the month. Now technically this is not the number of days in the month, it's the number of work days. So that would be a pretty grueling job if you had to work 30 days in a month. But let's just pretend. So how many days will Brian work? Well, he's going to miss 3 days of work. So that means he would work 27 days. And while hopefully you can do that in your head, what I really care more about is the 27, is I care about the process. How do we get 27? And that would be the 30 total work days minus the 3 that Brian's gonna miss, okay? Now from this, you might already know, be like, oh, I got the expression. But if not, let's maybe pick a couple other numbers of days. Maybe it's a different, most months have 4 weeks, 5 work days in a week, so that'd be 20 work days. So if there's 20 total days of work in the month and Brian misses 3, he's gonna work 17 days, and that's the 20 work days minus the 3 Brian's gonna miss. We'll do one more number. Again, you might see the pattern. You might say, oh, if it's W, I know what it's gonna be. But let's do one more. Let's say it's maybe a little shorter month. Maybe it's 15 work days in the month. So how many days would Brian work? Well, he's gonna miss 3, so he'll work for 12 days. The 15 days total minus the 3 he's gonna work. So the challenge here is to say, all right, but it's really supposed to be W work days. We're not told the number. These are all we're pretending. But do you see the pattern? I got a 30, and then I got 30 minus 3. I got 20, and then I got 20 minus 3. I got 15, and then I got 15 minus 3. So when I have W, the expression for how many days Brian will work is simply W minus 3. And that's it. I'll circle this up here, but that's it. That's the expression. However many work days there are in the month, minus the 3 Brian's going to miss, that is what Brian will work. And if you want to throw the word days on there, so that's it. That's our expression. I don't need an equal sign. I don't need an inequality. That's an expression. If there's W work days and Brian's going to miss 3, that means Brian will work W minus 3 days. Okay. Part B then asks us, or tells us, Brian wants to work over 20 days this month. If Brian is to meet his goal, how many work days can there be in the month? So here, the reason I split this into parts A and B, I could have just given you all this information and then just said, all right, here's this part here. I could have skipped part A, but I wanted to help lead you to part B. So I'm going to write it this way. I'm going to say Brian works W minus 3 days. We got that from part A. Brian works W minus 3 days. That's the expression, W minus 3. Brian wants to work, I'm just going to say Brian works 20 days. Brian works over 20 days. And so what I'm going to do with this is I'm going to say, all right, well, what Brian works is W minus 3. If it's going to be over 20, that means it's got to be greater than 20. So now I've written an inequality, and now I'm just going to solve that inequality. So now I'll come over here. If W minus 3 is greater than 20, we said that solving an inequality is just like solving an equation, except you have an inequality symbol in it, and sometimes you have to flip the inequality. But I would add 3 here to cancel the minus 3, balance there. I'd get just W here, let's go back to red, and I'd have is greater than 23. Now the only thing I would do here, because it's from a story, I would give my answer as a sentence. I would put it back into the story basically. So I would just say here, the question was how many work days can there be in the month? So then I would just say there can be, and I would use their word from the question. I would just use this over. We said over 20 would be greater than 20. Greater than 23 would be over 23. So there can be over 23 work days. And there's my answer. Okay. All right, and that's it. We've done number 13. All right, same quiz, but now we're on to number 14. That's story problem. Our story here says Kevin has $32. He plans to save X dollars from working over the summer. And then parts A and B. Part A again asks us for an expression, right? An expression to represent how much money Kevin has after saving. So again, an expression, no equal sign, no inequality. In our last problem, our expression was W minus 3, so we're going to have something like that. It wasn't W minus 3 equals something, or W minus 3 is less than or greater than, not for the expression. So again, I would hope that you could figure out like, oh yeah, he's got $32, he's going to save X dollars, how much money does he have after he saves? I hope you could come up with that, and with practice, you're going to be like, oh yeah, I know what to do. But if you're stuck, what you can do is you can pretend you know the value of X. So I'm going to make a little table here. We can talk about the dollars that are saved, and we can talk about the money after saving. And you can pick whatever numbers you like, but I'm just going to start with here. Pretend, I don't know if this would be a good summer or a bad summer. When I was a kid, this would have probably been great. If I saved up $1,000 over the summer. As a kid, that would have been a lot for me. So what would I have though after saving that $1,000? Well, I already had $32. So if I put that together, I'd have $1,032. But again, I don't really care about this number because I don't know it's 1,000. I care about the process. How do I get 1,032 from 1,000? Well, I take my $1,000 that I saved and I add it to the 32 I already had. So again, you might already be like, yep, I know what to do. I know the expression here. Okay, but let's try a different dollar amount if we want. Maybe I save $400. Again, as a kid, that probably would have been good for me. So what do I have after saving that $400? Well, put that with the 32 I already had. I got $432. The $400 I saved plus the $32 I started with. Do you see any patterns yet? Let's do one more. Let's talk about if we did, maybe I had a really bad summer and I spent most of the money I made, or maybe I didn't make a lot of money and I only saved $5. So what do I have after saving? Well, I've got the $5 along with the $32 I started with, so that would be $37. The $5 I saved plus the 32 I started with. So again, the idea is that we're pretending, we're making this up. I don't know that it was $1,000 or 400 or 5 or what number. We're making this up. So, but there's a pattern here. We're supposed to say for X dollars. If we save X dollars, how much do we have after saving? Well, look at the pattern. $1,000, we did 1,000 plus 32. $400. Oh, whoops, let's circle that one up. $1,000, 1,000 plus 32. $400, 400 plus 32. $5, 5 plus 32. So if it's X dollars, I go, it doesn't matter what this number is, we're always adding 32. So that's what our expression is going to be, X plus 32. And I can't tell you what that equals without more information, but that's our expression. Kevin will have, after saving, X plus 32, and you could say dollars if you want to, but that's our expression. That's it. What I saved plus the 32 I started with. Okay, so again, I hope you could get that right away just from the description, but if you're stuck, if you're like, I have no idea what to do, those variables are confusing, give yourself some solid numbers. Give yourself some examples. And what if you knew that amount? What if you knew that value? What would you do? You would add 32. So even if you don't know the number, you can still say, let's add 32. Okay. All right, for them, part B says Kevin would like to have enough money to buy an iPod, which costs $150. How much money can Kevin save up in order to buy the iPod? Now, one thing I like to point out here, whereas number 13 had the word, I think it was over, and it's like, ooh, over 20 days or whatever it was, over 20 days, that's more than 20 days. Here I go, there's not really a word that indicates an inequality. But if you think about the situation, if I'm going to buy an iPod for $150, it's okay for me to have exactly $150, if that's what the price is, with, after tax or if there is no tax. But it's also okay if I have more than $150. So I would just point out here that we could say Kevin needs at least $150. It's okay if I go to the store and I go, hey, iPod costs $150 total, I've got $150, okay, buy your iPod. But if I go to the store with $200, I'll still be able to buy the iPod. They'll say, here's your change for $50. You spent $150 on the iPod, here's $50 in change. So at least $150, okay? So breaking this down, we could say that Kevin has X plus $32. We got that from part A. Kevin has X plus 32. And then to buy the iPod, Kevin has at least 150. And that's two words, by the way, at least. Okay, so now I'm going to translate this. I'm going to use my expression, and I'm going to translate this into an algebraic inequality. So what I have is X plus 32. At least, this is one of those phrases to practice, at least 150 means 150 or more. So that is greater than or equal to 150. And now all I have to do is solve my inequality. Okay, so I'll do that over here. X plus 32 is greater than or equal to 150. What I save is 150 or more. And then I just have to solve my inequality. I'll subtract 32 on both sides. And we'll end up with X being, if I'm doing my mental math correctly here, X is greater than or equal to 118. And again, because this was a story, I like to give my answer as a sentence. So Kevin can save $118 or more. Doesn't have to be exactly 118. I save up 118 bucks, put that with the 32 I've got. Hey, boom, I got 150 exactly. But I go, what if you want to save up 200? What if you want to save up 400? I'll have enough to buy the iPod. Okay. All right, so there you go. I hope that helped. And yeah, keep practicing.